Hello everyone, Kyle here, an engineer from Vancouver, British Columbia. Today we're going to be learning how to track objects in real time, but instead of using our color tracking that we've learned in previous tutorials, today we're going to learn how to track objects without color. Now more specifically, today we're going to be looking at the method of sequential images. And what that entails is we're going to read one frame of the video feed and then another, and we're going to compare these two frames, and we're going to see which pixels have changed between the two images. And I'd like you all to think about this as kind of the way that the human eye and human brain will, detect movement. If you have a scene where the background is still and you have, let's say, a bouncing ball, you can definitely tell that the ball is moving because it's moving in relation to the background, the still background. Now we're going to start out with the most basic example you can think of. The picture above is just my desktop. Actually, the top of my desk that my computer rests on is just black, and in the second image, I've placed a coin in the middle. Now, in OpenCV, we can actually call a function which is going to compare the two images, and it's going to take the absolute difference between the two pixels, the two matrices of pixels on each of the images. And once it does that, we're going to be left with a threshold image. Now, what the threshold image represents, it's going to represent which pixels have changed between the two images that we're comparing. Now, if you followed along in the previous tutorials, you'll know that if this threshold image represents the object that we're trying to detect, we know how to deal with this. We can employ the exact same methods that we used in the previous tutorial to track our objects. In reality, we're not going to be dealing with such a simple case where the coin is there, just magically appears, and we're left with a perfect threshold image of the object that we're trying to track. Instead, since the two frames are being compared to each other and the object will be moving, it's not just going to have the object in its next position, it's also going to capture its previous position. So, we'll be left with something kind of like an oval shape from the previous image and the next image. Furthermore, there's actually going to be a overlapping region between the two positions. In this overlapping region, it's just caused by the two images kind of being blurred together. And what we're going to be left with is a bit of a black hole in between the two positions of the coin. So let's take a look at a quick example here, so you can get a better kind of visual idea of what I'm talking about. On the right, we have a video feed of a ball rolling by, a tennis ball. And on the left, I've written some code such that we can take the absolute difference of the two frames sequentially. And if we pause, we can kind of see evidence of what I was talking about earlier, with that bit of overlap between the two frames. If we go back one more time, we can actually see that in some cases the ball will be moving so fast that between the two frames, the positions are so far apart that it actually looks like there are two objects. But hey, it's no time to get picky. We'll work with what we got. This method of object tracking is a little more advanced, and that's why it's a bit more tough to deal with. But enough talking about theory. Let's jump into the code. If you can start out by downloading the file from below. This zip file is going to contain both the source file and a sample video that we're going to be using. The video is going to be the one that you saw earlier with the bouncing ball. And by the end of this tutorial, you're going to be able to track that ball using the method of sequential images that we've just discussed. We're going to start out by setting up our Visual Studio project. If you already know how to do this, you can just skip ahead to the next section. But if not, just follow along. We're going to select New Project, and then the name of this project, I'm going to call it Motion Tracking. And then click Next, and Console Application, and Empty Project. Then we're going to head to the Property Manager, and we're going to add in our debug, we're going to add our existing property sheet. I have mine saved in my main project directory. And here you see it under debug. We learned how to make that in the installation guide. If you haven't done that yet, you can head there and check that out. Alright, now that we've linked our project to the OpenCV library, we're going to head to the zip file that we just downloaded. And we're going to extract it to our Visual Studio project folder. Mine is in my documents, and then Visual Studio 2010, and under projects, and motion tracking. One more folder in, motion tracking, and then we'll say OK. Extract. So you should see both your new source file and your video in our project folder. I'll head back to Visual Studio, and we're going to right click on source files, and we're going to add an existing item, and we're going to select the motion tracking source file that we just added to the folder. We're going to add it to our project and open it up. Alright, if we click compile and run the program, we'll see that we have a bouncing ball video. It's just going to be looping. Once it reaches the last frame, it's just going to reopen the video and play it again. So it's good, making sure that all works. So we scroll down, I just want to kind of explain how this code works right now. If you scroll down to the main function, we can see that we have a main while loop that's infinitely looping. In this main while loop, we open up our bouncing ball video. Within this loop, we have another while loop which tests the current frame position of the video against the total frame count of the video. And when the current frame count equals the total frame count, we know we've reached the end of the video. At this point, we can release the capture and reopen the video and do it all over again. And that's how we get a repeating video. So right now, in our second while loop, all we're doing is reading a frame and later displaying that frame. In between, you can see that we have a bunch of comments here. And what I aim to do is to go through step by step by step and fill in the code relative to these comments. If we go up to the top here, at the beginning of our main function, we can see that I've provided a couple Boolean variables and some matrices, and we're going to be using those, so you don't need to worry about defining any of them. Now what I've done with the Boolean variables is actually set up some keystroke listeners so that you don't need to get all this code here. It's basically just for your convenience. We can use the T button to toggle tracking between true and false. We can also use D to turn on and turn off debug mode, or P to pause and resume the code. And when we press P to pause the code, it's actually just going to enter an infinite loop and not run any of the code until you press P again to resume. So I hope that makes enough sense so we can scroll up and start coding. I'm actually going to skip a couple steps and go straight to our AbsDiv function that I talked about earlier. It's going to take the absolute difference between two frames. We can see that it is asking for one frame and then another frame. And that's also asking for a matrix to store the destination frame, or the output of this function. One good thing to note is that the first frame and the second frame, they actually need to be grayscale images. So they need to be in basically black and white. So before we use our AbsDiv function, we're going to convert our frames to grayscale. And how we're going to do that is we're going to use the CV function called convertcolor. If we open that up, you can see it's asking for the source frame. We're going to put in frame 1. And for the output, I believe I've actually initialized a couple variables. Yes, gray image 1 and gray image 2. We're going to use those. Why not? So gray image 1. And then it's asking for the code in which it's kind of like the conversion code, if you will. For this one, we're going to type in, I know it's one of the color ones, so if we press color and then hit Control Space, we can see a whole bunch of options, and I believe it's BGR to gray. And by the time the color's been converted, our second frame should be ready to capture. It's actually good to note that if you were to just say capture frame 1 and then frame 2, there might not be enough delay in the code to actually have shifted to the next frame. So I would make sure that you have the convert color before you capture your second frame. And then we're going to do the exact same thing. We're going to convert it to grayscale. We can just copy and paste, change our 1s to 2s. And then we're ready to use our AbsDiv function. So if we check it out again, we can see we're going to put in our grayscale images. So gray image 1, gray image 2. And our destination, let's see which one I've used for this. Okay, we're going to use difference image. I mean, you can call it whatever you want, but you gotta initialize it first, so I've done that for you already. Now I know I said earlier that the absolute difference function is going to take the 2 frames and it's going to output a threshold image which we're going to be able to use to track the object. What really is the case is that this absolute difference function outputs what's called a intensity image, or what I've called a difference image. And this type of image actually doesn't just show black and white or zeros and ones. It actually has values between 0 and 1, so there is some gray in there too. And what we're going to have to do is we're going to have to use a threshold function to get just black and white. So let's go ahead and do that now. We're going to go below this comment and use the CV function threshold. The first argument it's going to ask for its input, we're going to use our difference image. And for the output, we're going to want our threshold image. And I've defined it up here. I've called it threshold image. You can just copy and paste it into there or type it out. The third value, now that's an interesting one actually. I've renamed it to what's called sensitivity value, because if you have too low of a value for this threshold, it's going to actually let in too much noise. But if you have maybe, let's say, the object is really small and you can't really detect it without letting in a little bit of noise, then maybe you might want to lower your sensitivity value and just risk having a bit of noise. I've set the sensitivity value for us today at 20. It seems to be a pretty good value. I don't see any noise and it's tracking the object pretty well. So let's just use sensitivity value. This max val, that's the maximum value. It's between 0 and 255, so just use 255. And the type, we're going to use this CV value called thresh binary, I believe. Yep. So that's going to output a binary threshold image for us. Now, when working with computer vision, I always like to have a debug mode, because you always want to see where your code is going wrong. So if you can see the threshold image, the difference image, and see what they look like, you can find what's wrong with your image tracking. So to show the windows, we're just going to use the CV function imShow, and let's just call it difference image, and we're going to use the difference image. And we're also going to show our threshold image. Now, one good thing to note is that once you show these windows, if you don't destroy them after when you click debug mode off, then it's going to leave up the blank frame there, and you don't want that. So there's also a CV function called destroy window, and we'll just use what we typed in here. These two have to be the same. You have to specify the same name. Let's repeat that again, and this time for the threshold image. Alright, let's run the program and see what we got so far. We can just see we just have the bouncing ball because I have not initialized debug mode yet. So if you click on the window and click D, debug mode will be enabled, and we can see our difference image and threshold image. Now you can almost barely see the difference image because it has everything ranging from black to white, so there's some gray in there. It's not just black and white. Our threshold image is black and white, so I'm gonna pause the program by pressing P so we can compare the three here. Let's actually find a bit of a better spot to pause it at. There we go. So if we zoom in to our colored picture, we can see tiny little smudge here. And over to our difference image, also pretty small, but you can see it. And finally down to the threshold image, we can see a little bit of white speck here. And you might be thinking right away, that doesn't seem like enough information to give our program to try and find the object. We should probably use something similar to last time, where we use the dilate and erode function to expand our white space. And you would be absolutely right. We do have to do something about this small amount of white space that we're getting. Instead of using the dilate and erode functions like we did last time, I'm going to introduce a new one. It's a CV function called blur. And the arguments that it takes is going to take an input image and an output image. We're not going to define any more variables. I'm just going to use the threshold image and save it in the threshold image as well. Now it's asking for a size of the blur, and that's similar to the size that we used to dilate last time. So we just use the CV type size, and I've already defined a size at the top here. You can fiddle around with this as well just to see what happens, but you're going to want to use blur size, which is 10 for us. Just enter blur size, comma, blur size, and then close the bracket. So after we've blurred it, it's going to unfortunately output an intensity image from this function. So we're going to have to use the threshold function that we used before, but it doesn't matter. We can do basically the same thing. Let's use threshold image twice. We're going to use sensitivity value, same one, max val 255, and thresh binary as well. And just like before, we're going to use our debug mode for our advantage here. And we're going to show, let's just say, final threshold image, and we'll show our threshold image. And just like before, we're going to want to destroy the window after debug mode is turned off. Now, if that wasn't too complicated for you, let's run it and see what we get. Once again, click D for debug mode. And would you look at that? Our final threshold image, much better than our previous threshold image. And if we pause it, we can see we have increased that white space, almost made it into just one single object instead of two up top there. And I think it's about time to use our tracking function so that we can track this object. So to track our image, I've made a function very similar to one in the last tutorial. I've named it search for movement. So it's going to search for that little white space of the ball. Basically what we do is we use the find contours function again. We draw a bounding rectangle. We use the centroid of the bounding rectangle around the contour, and we find the middle of the object. It's pretty simple. I encourage you to look through the code, try and understand it the best you can. I'm not going to go through it because that would take too much time. But we have also the drawing function, which is going to draw some crosshairs, tell us that we're tracking an object at X and Y, and it looks pretty cool altogether. So if you scroll back down to below this comment here, if tracking enabled, we're going to do that exact thing. We're going to use our if tracking enabled equals true. I've already defined that up top. It's set to false right now, but remember we have those keystrokes. So if we click T, it's going to click tracking enabled to true. So let's call our search for movement function. Search for movement. It's going to ask for our threshold image, which we have prepared. And it's asking for the camera feed. That's just to draw the... Actually, let's just see what it is. I called it frame 1. We'll just draw it to frame 1. That's we pass in the frame to the search for movement function, and it's going to draw to it and then give it back to us, and then we can just show it right here. So if all is working well, we should be able to track this object. So let's check it out. Click run. We can click D just to make sure the debug's working. Looks great. Looks great. Press D again. Turn it off. Our destroy windows are working great too. And now if we press T, can see that our object is being tracked in real time. I'd say it's working pretty well too. It's definitely following the ball along. It's moving pretty quickly here, so we'll pause it. And you can do so too by pressing P on your keyboard. We can just see that it says tracking object at 291 and 333, and that's just our pixel values, our X and Y pixel values. Now, a few things I'd like to mention before you go off and use this code for yourself. If you go down to this wait key statement, you can change that to any value you want. Right now it's at delaying 10 milliseconds. If you figure like your code's going too fast, just change it to 30 or 40 or 50 or something. Also, if you scroll up to some of these values that I have defined here, the sensitivity value. Now, your sensitivity value, if you have problems with, let's say, noise or anything along like little white specks coming up on your feed there, you might want to increase it to something like 40 or maybe 50. And if you have a problem, the opposite problem, where maybe your threshold image isn't really showing anything at all, then you're going to want to lower your sensitivity value. You might let a bit of noise in, but you could probably get rid of that with the blur function. And since I mentioned the blur function, you can actually change this size to something bigger or smaller to suit your needs. And there's one final thing I'd like to add, is that if you want to use your own webcam for this instead of video input, you're going to have to change up the code a little bit, and I'm going to show you how to do that. First off, you're going to want to cut and paste this capture, and it's checking for errors here. You're going to want to cut and paste that outside of the while loop, because we don't need to open the video feed every time it reaches the last frame, because it's just a constant video, our video feed. And we're going to want to change our input to 0. That's going to get the first location of your webcam. You're then going to want to get rid of this while loop, because like I said, we don't need to check for the final frame and re-loop the video. We can just delete that. And then we're going to have to find the other bracket of that while loop. If we scroll down here, I know which one it is. It is this one. And another good thing to add is that we're going to have to not release the capture, because that's going to close the capture that you just opened. So delete that, and you should be good to go. Alright, so this concludes your lesson on fast object tracking without color using the method of sequential images. You can click here to subscribe. For next time, we're going to be looking at, we're actually going to make a DIY home surveillance camera using this exact technique, as well as our video writing tutorial that I released about a month ago. And so stay tuned for that. And as always, thanks for watching.